And I've got to insert a note here real quick. This is for my online students. This is where we kind of left off on our video since the stream messed up earlier today. So just pick up here, okay? That's for my other students. All right. So we have what is essentially two quadratics equal to each other. Well, like I said with the previous example, ideally we want this equal to 0, okay? Because then we can solve and we can say, all right, well, this times this equals 0, so one of them's got to be 0 and solve it all the way, okay? So again, we'd like this to be equal to 0. So what we can do is we can move everything on this side over here, and then we will have something equal to 0. Does that make sense? Okay. So for instance, like I can move 7, minus 7z squared on both sides. Zoom in a little bit. So that'll give us a single z squared here. Then minus 20z on both sides. Okay, that's going to give us negative 10z here. And then add 13 to both sides. And that'll give us 16. And again, because we eliminated everything on this side, that means this is now equal to 0. Again, that's our ideal equation there. This quadratic is equal to 0. And we solve it just like we did the previous one. So it's time for AC method. My A is 1, my C is 16. 1 times 16, 16. All right, factors of 16, there aren't too many. 1 and 16, 4 and 4, 2 and 8. And we need a pair that will give us negative 10 here in the middle. Well, if I make this negative 2 and negative 8, negative 2 plus negative 8 is negative 10. So I'll rewrite this now. This is now z squared minus 2z minus 8z plus 16 equals 0. Again, at this point, we could use our shortcut method. Our A is positive 1, so we can go directly to our factors. But I want the practice with the box method, so let's do the box method. Okay, so first term goes in the first box, z squared. Then the last term goes in the last box, 16. And these two in the middle doesn't really matter, just as long as we remember that their signs come along with them and sit on the outside. So 2z I'll put right there. I really need a new pen. And its negative goes on the outside. 8z, same idea. Its negative goes on the outside. So now let's see if we can factor this. This first row, what can we take out? Z, good. How about this second row? Bigger than 4, actually. 8, yeah. 4 can come out, you're right, but 8, we're looking for the largest factor, so 8 is the largest one. Good. This column here, Z, and this column here, 2. Okay, so our two factors are Z minus 2 and Z minus 8. And again, like we said with the previous example, this is no different from this. They're just saying it in a different way, but they have the exact same idea behind them. So we can say that if this is equal to 0, then this is also equal to 0. Okay. So again, we say we have one number times another number. This is one number all on its own. This is another number. They both have different values. But somehow, when we multiply this number times this number, we get 0. And there's only one way for that to happen, and that is one of these numbers would have to be 0. So we say, all right, Z minus 2 could be the number that is 0. But as well, Z minus 8 could also be the number that is 0. So we solve now. Subtract 2 from both sides here, we get Z equals, add 2 to both sides, we get Z equals 2. Add 8 to both sides here, we get Z equals 8. In other words, Z could be two things. Z could be 2, or Z could be 8. Either one would actually make this original equation work. We plugged in 2 for Z here, it would make these both equal to each other. If we plugged 8 in for Z here, it'd still make both these equal. This has more than one answer. Now, this question is going to be on the quiz. Does that mean, is it a contradiction? Is it an identity? Is it a conditional? Well, remember that a conditional equation has a limited amount of answers, but you can have more than one. A conditional equation has some condition that makes the equation true. In this case, the condition is that Z has to be either 2 or 8. So it has an exact amount of answers. An identity has an infinite amount of answers. In other words, any number you plug in there would work. Well, we can't plug in any number for this one. It's got to be 2 or 8, so it's not an identity. In a contradiction, no answers work. There's no answer. Well, we definitely have 2 answers here, so this is still a conditional. Any questions? All right. Now, quadratic equations are typically going to have 2 answers. That's what we're usually going to see in this class, is they have 2 answers. Every once in a while, like with our first example, we will have 1 answer, but that's not going to happen all the time. Okay? All right, let's try another one. This one's a little bit tricky. We've got y squared minus 2y equals negative 65. Okay. So, like I said, ideally, these equations we want to get equal to 0. So what would we do? Add 65. So that would give us y squared minus 2y equals positive 65. Oh, whoops. Y squared minus 2y plus 65 equals 0. Sorry about the messiness. Okay. Well, AC method. Our A is 1, our C is 65, so our AC is 65. Let's see, factors of 65, that'd be 1 and 65, 5 and 13. That's all of them. Now remember, what we want from these is a pair of those factors that will add to get negative 2. Well, difference of 1 and 65 is 64. Difference of 5 and 13 is 8. There's no way that we can combine either of these pairs and get negative 2. Nothing will work. So what does this mean? It means that this particular equation, this quadratic, cannot be factored. We can't do anything to make this factored. Okay? So does that mean that we have to give up? That there's no answer for this? No. We just have to change our tactics a little bit. So this, as it is right now, cannot be factored. But there is a way that we can force it into a form that will factor. Okay? Now what we're going to do here is something called complete the square. And I'm not going to quiz us a whole lot over it. I'm going to show you an alternative to it, but I want to show you how it works first. Okay? So again, this cannot be factored just as it is, but we can change it into a form that will factor. What we'll do is we'll get the y's by themselves. We don't want anything but these y values. So we'll put that 65 back on the other side. So we got y squared minus 2y equals negative 65. Okay. Now in order for this to work, first of all, our a term, our leading coefficient, has to be positive 1. If it isn't, we need to divide it out so that it is 1. Luckily for us, it's already 1. Now what we do is we look at this side and we say, all right, we've got y squared minus 2y. We can add something to this. We can add a c term to this that will make it factorable. With the 65, it wasn't factorable, but we can add a different number to this side to make it factorable, something that isn't 65. And the way we find a number that will work is we look at this middle number, take half of it, and square it. So half of 2 is 1. 1 squared is 1. So the magic number that will make this thing factorable if we add is 1. So we'll do now y squared minus 2y plus 1. This is now a factorable quadratic. However, remember, equations show balance. If we add 1 to one side, it's going to throw the balance off to that side. So we've got to also add 1 to this side. So 65 or negative 65 plus 1 is negative 64. Okay, and then we can factor this. There's actually a really quick way to factor this thing. When you make this factorable, you make what's called a perfect square trinomial. And that's just a fancy way of saying it's a really easy thing to factor. Okay? What you do is you open up a set of parentheses. See this variable? Write it down. We have y. Not y squared, just y. See this sign right here? Negative? Write it down. Take half of this number, which is 1, write it down. Close your parentheses and square it. That's now factored. Excuse me? A perfect square trinomial. It factors to something that is squared. So in this case, it's y minus 1 squared. Another way you could say that is y minus 1 times y minus 1. Its pair of factors will always be the same. In fact, the one that I gave us at the beginning of class today, that's a perfect square trinomial. Half of this is 2, 2 squared is 4. I added 4 to this side to make it a perfect square trinomial. Okay, and if we look, its factors are x plus 2 and x plus 2, or we could say x plus 2 squared. Okay, so this is now equal to negative 64. And we can solve this. First, we want to get rid of this square so that we can get to the y at negative 1. So the opposite of a square is a square root, and those will cancel, leaving us just y minus 1. Now on this side, what is the square root of just a regular 64? Not negative, just a regular 64. What's the square root of 64? 8. Okay, now this is negative 8. So it's going to be not 8, but 8 what? 8 what? No. When we take the square root of a negative number, that negative becomes I. So the square root of negative 64 is 8i. And one more thing. I've been mentioning this throughout the semester, but last time I mentioned it, I said we need to remember that roots from now on don't have one answer. When we say that the square root of 16 is 4, what we really need to say that the square root of 16 is positive 4 or negative 4. And it's the same thing here. The square root of negative 64 is positive 8i or negative 8i. Every root that we take from now on is going to have two answers, a positive and a negative. We write it like that. It's called plus or minus. And I got to stress that from this point on, when you take a root, it is positive or negative the answer. And then from this point, we just need to add 1. And we get y equals 1 plus or minus 8i. And there's our answer. Like I said before, we're usually looking for two answers, right? Like this one had z equals 2 or z equals 8. This one also has two answers. Our two answers are 1 plus 8i or 1 minus 8i. Does that make sense? Okay. Any questions on this one? No? Okay. So this one did not factor. We had to use something else to try and solve it. And we used complete the square method. Can you say that again? Yeah. So this is the form of a perfect square trinomial. And we get that by using the complete the square method. So complete the square is the method. Now, again, complete the square, we're not going to really worry too much about that one this semester because there's an alternative. Remember that all of these quadratic things have a form to them. It's ax squared plus bx plus c. That's where we get our AC method from. Now, if I set this thing equal to 0, I can use my complete the square method on it. Now, I'm going to show it. You don't need to take notes on how to get from this point to the next one. You don't need to know anything about it. You just need to know that this is how we get to what we're going to use. Okay. Leading coefficient must be 1. Right now it's a. We divide everything by a. That gives us x squared plus b divided by a x plus c over a equals 0. We want the x's by themselves, so we move c over a. We take half of this number and square it. So half of this number, in other words, b over a times 1/2, would be b over 2a. And we will add that to both sides. Okay. Now, remember, this should now be a perfect square trinomial, since we added that magic number to the end. We need to add it to this as well to make sure that there's balance. Okay? So here we're going to factor. We take this variable, write it down, this sign, write it down, and half of this and write it down. So b over 2a, and then square the whole thing. We need to add these together. Well, they need to have like common denominators, right? So we'll multiply the bottom by 2 to make both of these 2a. Combining that, we get b minus c all over 2 times a. I'm sorry, b minus 2c. Still with me? Okay, don't need to be, just showing it for your benefit. We want to get x by itself, so we take the square root of both sides to get rid of that square. That gives us x plus b over 2a equals the square root of b minus 2c all over 2a. Okay? Now, again, we want to get x by itself. So we're going to subtract b minus 2a. Okay? So now we have x equals, if we times it by, or I'm sorry, if we add this, that'd be negative b over 2a. What? Oh, sorry. Plus the square root of b minus 2, 2c all over 2a. Getting there. This technically is already solved. We've got x by itself. Okay? But this is a little bit complicated. We can clean it up a bit. And it cleans up to x equals negative b plus or minus, oops, forgot the plus or minus. Is me already doing it. Because remember, we took the square root of this side. So whatever this answer would be, it's plus or minus that. The square root of b squared minus 4 times a times c all over 2a. Okay? So again, this technically is solved, but I clean it up a little bit and get this. This is what is known as the quadratic formula. This can solve any quadratic equation. No matter what you throw at it. Is it factorable? It does not care. Is it got non-real numbers for answers? It does not care. Any kind of quadratic equation you throw at this thing, it will solve it. And I'll show you what I mean. So let's have x squared minus x minus 12 equals 0. What we do is we say, all right, what's our a, what's our b, what's our c, and we plug them into here. So my a is this number out in front of x squared, that's 1. My b is, again, a 1. My c is negative 12. So let's just write that down. A equals 1, b equals negative 1, c equals negative 12. And I plug them into this and get x equals negative b. So b is negative 1, negative 1 is positive 1, plus or minus the square root of b squared. Again, negative 1 is our b, so negative 1 squared is 1. Minus 4 times a times c. So minus 4 times a, which is 1, so 4, times negative 12. I guess I'll stick the 1 on there just to have it. All over 2 times a, which is 1, which would just be 2. Okay. So let's simplify this part in here. Negative 4 times negative 12. Let's see, that would be positive 48. And then times 1, still positive 48. 1 minus 48 is, I'm sorry, 1 plus 48 is 49. So it quickly simplifies down to this. What's the square root of 49? 7. So what we really have is x equals plus or 1 plus or minus 7 over 2. So now we can split this up into plus and minus. So 1 plus 7 is 8 divided by 2 is 4. So x could be 4. 1 minus 7 is negative 6. Negative 6 divided by 2 is negative 3. So in this case, x could be 4 or -3. Big thing is, I want you to write this down somewhere and try to memorize it. Because this is your best friend when dealing with quadratics. If you want to solve a quadratic equation, this will do it every time. Again, it doesn't matter if it's factorable or not. Actually, it doesn't matter if it's a difference of squares or not. It doesn't matter what form it's in. As long as you can find A, B, and C and plug them in here, it'll work. And it's done just by taking the normal form of a quadratic and complete the square to it. And you get this. Any questions? No? All right, again, as long as you have that written down, is what I want for today. So I think that will do it for today. Again, we started early, so you get to leave early. And I will see you on Wednesday. We'll be continuing on with this. But other than that, I hope you have a good day, and I'll see you Wednesday.